My name is Yujiro Ichikawa. I am from the Center for Environmental Science in Saitama, also known as CES. The title of this lecture is Basics of VOC Measurement using Sorbent Tubes. First, let me explain the difference between absorption and adsorption. The phenomenon of absorption is that atoms, ions, or molecules of gases, liquids, or solids are dissolved in another substance. You can see the phenomenon in the figure below. The phenomenon of absorption is that atoms, ions, or molecules of gases, liquids, or solids are retained on the surface of a solid or liquid substance as shown in the figure below. For solvent 2, they absorb VOCs. Okay, next is the tube material of the solvent 2. The three basic types are glass, stainless, and inert stainless. Length is 3.5 inch or 89 millimeter. Outer diameter is 1.25 inch or 6.4 millimeters. Of these three types, I recommend stainless steel or inert stainless steel. The reason is that they are easy to handle because they are rigid and the tubes will not crack or peel. In addition, inert tubes does not surface absorb active compounds. So inert tubes is probably the best ones to choose. However, inert stainless type is expensive and they are about 1.5 times higher. The cost is higher than stainless. So what do you think is the inside of these tubes are like? Here is the drawing of the inside of the solvent tube. It differs a little bit depending on the manufacturer, but the basics are the same. There is a thin part, so-called corsets, at the tube, and generally wire cloth is fixed in this part, and the solvent bed, which is the adsorption part, is filled behind the wired cloth. Behind the solvent bed, some manufacturers use G-grip to hold wire in place, while other manufacturers use springs to secure glass wool plugs. From this slide, I will describe the type of solvent material that is filled as solvent bed. Porous polymers are often used for medium to high boiling point VOC with carbon number between 5 and 30. Tenax is the popular one. And for graphitized carbon black, they are often used for low to medium boiling point VOC with carbon number from 3 to 20. Carbograph, Carbopack, Carbotrap are the ones that are often used. Carbonized molecule sieves are often used for low boiling VOC with carbon number ranging from 2 to 8. Popular ones are carbosieve or carboxyn. And zeolite molecule sieve is used as an adsorption for inorganic gases and is not generally used for VOC sampling. As you can see, there are many different types of solvent material depending on the target VOC. Manufacturers like Spelco, Camsco, and Exegla can produce customized Sorbent tubes upon request. As for filling Sorbent materials, there are single bed and multi-bed Sorbent types. A single bed is a type with one type Sorbent material filled inside, and multi-bed is one that is filled with two or more Sorbent materials. Multi-bed type is more expensive, but it can absorb various components at the same time, so it is suitable for simultaneous VOC measurement. There is a direction to put the Sorbent materials into multi-bed type. The sample inlet is the colset side. A weak adsorption capacity is placed on the inlet side, and a stronger Sorbent material is placed on the back. When you are sampling, the flow is in the direction of the blue arrow. And when you are setting the tubes to the thermal desorption equipment for measurement, the flow is in the purple arrow direction. The sampling using the Sorbent tube is called active sampling. The active sampling is sampling method where sample gas is actively collected in a collection tube, or you can say Sorbent tube, using a sampling pump. As shown in the figure, a pump is used to collect the atmosphere and absorb only the target VOC into the Sorbent tube. And most of the inorganic gases that you are not interested, such as nitrogen, argon, carbon dioxide, so on, passes through. The sampling volume is obtained by multiplying the sampling flow rate and the sample time. It depends on the type of Sorbent tube, but in general, sampling is done at the flow rate less than 250 milliliters per minute. Now I will explain about the breakthrough that you need to be aware of during sampling. As you see here, breakthrough is a phenomenon that the target components are not absorbed completely and goes through the Sorbent tube. Breakthrough occurs when high flow rates or when the sampling volume is too high. This happens because the absorption capacity of the tube is exceeded. Here I will explain two ways to find out whether absorption tubes breakthrough is occurring or not. The first one is to collect air under sampling condition by connecting two same tube in series. When connecting the tubes, the best choice is using stainless steel pipe, but it is practically difficult to use them. So the second choice is to use PTFE tube, which has less contamination and absorption than other material tubes. If target VOC components are not detected from the post-stage Sorbent tube, that means breakthrough is not occurring. And second one is comparison of these same two solvent tubes with different sampling volume. In this instance, if the VOC components measurement value are the same for the 2 liters and 6 liter sampling, then you can say that breakthrough is not occurring under the high sampling volume of 6 liter condition. In addition to breakthrough, there is another thing to keep in mind during sampling, and that is the issue of humidity. Humidity problems during sampling is that water vapor can mask the active sites of the solvent, and which will reduce adsorption capacity. And water vapor can, in some cases, displace compounds, which will decrease the recovery of those compounds. Next will be humidity problem during analysis. Water vapor can cause chromatographic separation issues. Second, water vapor can reduce the vacuum of an MS detector. Third, water vapor can decrease the sensitivity of MS detector. All of these issues are very important for accurate measurement. Here, I will explain about the relationship between solvent materials and humidity. From this slide, you can see that porous polymer and graphitized carbon black are hydrophobic, and carbonized molecule sieves are in the middle, and zeolite molecule sieves are hydrophilic. So when sampling is problematic in humidity environment, use a hydrophobic solvent tube like porous polymer or graphitized carbon black, or connect dehumidifying tube in front. So I have explained the problems that humidity brings, and you want to avoid the problems as much as possible. The measuring device for solvent tube sample, so-called thermal desorption system, which I will explain later in this lecture, has a dry purging function to remove the unwanted effects of humidity as much as possible prior to measurement. As you can see from the upper figure, drying purge is to pass through enough dry inner gas like helium or nitrogen gas to the solvent tube and carry the remaining water away. However, too much dry purge can start to push out the compounds of interest through the tube, so you will need to be aware of that situation. The approximate amount of dry purge for each type of tube is as noted below. For porous polymer and graphitized carbon black is about 0.25 liters, and carbonized molecular sieve would need 0.5 to 3 liters depending on humidity level. I will now use several slides to step through the key points of sampling procedure. Number 1. Solvent tube. Select the adsorption tube that best suits your sampling application. Number 2. Sampling pump. Select pumps that are capable of operating in the range of 4 to 250 milliliters per minute. And number 3, this is optional depending on the humidity level of the sampling circumstance, which is dehumidifying tube. As you can see in the picture on the right, a glass tube filled with about 50 grams of magnesium perchlorate. Generally, you cap both sides of the glass tube with quartz wool. Next, number 4, ozone scrubbers. This is optional too. When there is a possibility of decomposition of VOC components by ozone in the atmosphere, an ozone scrubber like magnesium dioxide or potassium iodide should be pre-connected to the solvent tube. And number 5, connection to stainless steel inert or 304 or GC grade is most robust tube material, but they are awkward to handle, especially in the field sampling situation. So alternatively pre-treated PTFE can also be used after blank test to ensure that there is no contamination or adsorption of VOC components. I usually pre-treat PTFE tube in an oven at 50 to 60 Celsius for several hours before use. Number 6, tube conditioning. Solvent tubes should be adequately conditioned using elevated temperatures and a flow of ultra-pure inert gas like helium or nitrogen for several hours. The photo here shows the solvent tubes being conditioned in the oven. Number 7, at the monitoring location. I recommend to wear clean gloves because your hand oil can sometimes be a source of contamination. And installation of shelter at the sample inlet to prevent extreme weather condition. You should prepare field blanks at the frequency of about 1 in every 10 samples. If you are all ready, set and adjust pump flow rate and sampling time. And don't forget to fill in the field data sheet. After field sampling, sample storage is performed at the lab. Sample tubes should be refrigerated or stored in a clean environment at the low temperature. Storage with activated charcoal is recommended as shown in the picture below. Now I will explain how to spike the standard gas to the solvent tube. This is the preparation step for the calibration curve which you will need for the GCMS measurement. As shown in the photo on the left, the manufacturer sells a kit to spike the standard gas. You fix the solvent tube with inert gas like helium or nitrogen flowing in. Take standard gas with a gas-tight syringe. If you are using standard solution, you will use a micro syringe. Spike to individual tubes with different amounts or concentrations of standards for calibration curve. After standard is added, pass through inert gas for several minutes to promote adsorption. If we are using standard solution, this procedure will also work to remove the solvent. Solvent tube samples are measured by thermal desorption GCMS or thermal desorption GCFID. This photo shows the equipment used in my lab with the thermal desorption system on the right side and GCMS on the left side. From this slide, I will explain the step-by-step flow of thermal desorption GCMS measurement. The left part is the thermal desorption system, and the right part is the GCMS. After the solvent tube is set to the thermal desorption system, all flow paths are closed to conduct leak check with a pressure transducer. Then only solvent tube and trap tube flow path are opened to check for leak checks in the flow path. If there is no problem with the leak check, you will move on to the dry purge procedure to remove any water remaining in the solvent tube, and also to replace the gas of flow path. Then the solvent tube is heated to thermally desorb the VOC components, which are indicated by a colored circle. This step is called primary desorption. Some amount are reabsorbed in cooled built-in trap tube, and some are eliminated by inlet split. The reason why some portion of sample is eliminated by inlet split is that if the total amount is sent to the trap tube, the absorption capacity of the trap tube may be exceeded, and that won't be accurate measurement. The trap tube is then heated, and the VOC components are desorbed and injected to the GCMS. At this time, some of the sample is eliminated by outlet split. This outlet split event is conducted because if too much sample amount is injected to GCMS, that will make the peak shape broad and peak separation poor. This slide shows the trap tube built into the thermal desorption system. Similar to the solvent tube, there are many types of trap tubes. They can also be customized by manufacturer to meet your needs. You can choose the type of trap tube depending on the VOC component you are interested in. And this will be the last slide for this lecture. In the measurement with the solvent tube, after taking a few liters of sample, a few milliliters of sample is sent to the trap tube, which is built in the thermal desorption system. And finally, a few microliters are introduced for GCMS measurement. This is a very highly sensitive measurement with a concentration ratio of 10,000 to 100,000. I hope this lecture will help you understand the basics of VOC measurement using solvent tube. Thank you very much.